Welcome to another episode of MrLopezClases.com. Today we are going to continue in our marine system book. And this is the chapter 2, hydraulic system. This is the episode number 3. Okay, in this moment we have cleared the concept about the Pascal law. And we understand that in order to get a hydraulic circuit, we need a motor, we need a pump, we need the lines, we need the cylinder or the load, and we need probably a pressure regulator in order to keep the pressure in the system regulated. Yes, this is constant. Those are the elements to create a hydraulic circuit. But those elements are special elements. The pumps have special characteristics, the lines have special characteristics, and the cylinders, of course, and the hydraulic motors. We are going to try to analyze all of those elements in details. And after that, we are going to try to understand the process to condensate all the hydraulic systems in one central unit in a boat. Yes, this is possible. In this episode and the next coming episode, we have great example in real boats where those systems are integrated. We are going to analyze all the hydraulic systems in the boat and how those systems can be integrated together in one hydraulic system. This is a wonderful episode, and the next coming episode is the complement of this episode. Okay, we are going to refresh quickly the typical hydraulic system. Remember, in a typical hydraulic system, for example, this is the steering system. We have the pump. Remember that in this particular case, the pump is a mechanical pump, the hand pump. The fluid is going for the starboard side, port side, and this is the return. Okay, the fluid enters for port side, starboard side, into the reservoir. The reservoir, in this particular case, the pump is manual, remember, because I moved the pump with my hands. It's manual pump. It's a hydraulic pump, manually activated. It's a hydraulic pump, manually activated. It's a mechanical hydraulic pump. Okay, you remember another mechanical hydraulic pump? Another mechanical hydraulic pump? You remember that one in your car? Exactly. This is the pulley that is connected with the bell of the crankshaft and the alternator. Yes, my friend, this is the pump. In this pump we have the reservoir and we have the valve body over there, and is manually activated or mechanically activated because it's with belt and pulley. This is the steering pump that you have in your car. Once again, it's a hydraulic, mechanical hydraulic pump. It's not electric. Alright, this is another example of mechanical pump. And of course, the lines, starboard side and port side, enter in the reservoir. The reservoir in hydraulic systems is a critical, is a vital component in hydraulic system, because in the reservoir I have different functions together in one container. We can check the level of the fluid, we can check the pressure of the system, we can add it pressure on the system with the air pump, and I can switch the valves, because this is the body valves. The body valves, the reservoir, the pressure gauge, and the pressure relief valve. Pressure relief valve, pressure gauge, and reservoir. This is important. If you have a hydraulic circuit, the reservoir is mandatory, because this is the container where the oil is condensated and where the oil is collected when the fluid passes through the motor and return. Okay, and after that the lines enter into the actuator. This is a special actuator. Right now we are going to talk about the actuator. This is double port, double shaft. Okay, and what is this? This is a special pump connected in series to add extra pressure in the system. This is the power assisted unit. It's electrical. I can activate that power assisted unit here. Right now it's activated with an external switch like this, or I can activate it directly with the ignition switch. When the ignition switch is on, that pump is activated. It's exactly the same like in your car. In your boat, that power assisted unit is electrical, is that one. And when the pump is activated, immediately move the wheel is too soft and the actuator move in both directions easily. Exactly the same like in your car. All right, this is the typical hydraulic system. Important, the lines, the quality of the lines, the quality of the fittings. Those lines are special lines. Those lines are reinforced lines. Those lines are hydraulically approved. Never try to use generic lines because you know the pressure that you administrate in those lines. It's a heavy pressure. For that reason, use only marine approved hydraulic lines. And of course the fittings, special fittings. There are a lot of fittings in different dimensions. For that reason, you can use flexible hoses or you can use rigid lines like in copper or stainless steel. In that case, you need the flare tool in order to do the flare, and the bending pipe, like the bending pipe that you have on the screen, to bend the pipes and to do the flares. And always use fittings marine approved. If the fittings are in copper, should be bronze, naval bronze. Never use brass fittings. The fittings that you buy in the general hardware storage departments, those are in brass for residential application, for building construction. Those fittings are not recommended in marine applications because those fittings in contact with the aluminum and copper, no good, and the more noble metal attack the less noble metal. In this particular case, for example, the body of valves of this equipment is in aluminum and those fittings are in naval bronze. If you use regular brass, immediately the aluminum is eroded. We are going to study in our course of corrosion that phenomenon. Okay, don't forget the line should be marine lines, approved lines, the fittings, all the fittings, these elbows, reducers, those fittings should be always marine grade. In other words, if I want to create a typical hydraulic circuit, I need the motor, the valve body, and the reservoir. The motor, the valve body, and the reservoir. That's it. In this particular case, the motor is an electric motor, DC motor, reversible motor. You remember I explained in our electrical class the process to reverse rotation in DC motors, that episode. Check that episode in order to verify how can I change the rotation in DC motors. Okay, but in some cases this motor is electric motor, AC motor, and we have the same situation. The AC motor, the body of valves, and the reservoir, like this. This is a typical central hydraulic unit. The reservoir, the body valves with the servo solenoids. Look, this is a body of valves, two positions. The central position is neutral, position for up, position for down, and this one in particular is controlled for a couple of solenoids. The solenoid receives the signal from the control, the push button on top. It is for a windlass, or from the control in the console. You have one servo valve for one element, probably bow thruster. You have another one servo valve for the garage door, and this motor is an AC motor. This is an AC motor. The other one that we have in the back is with a DC motor. If you check the solenoid and the DC motor, and once again you have the motor, reversible motor, and you have the reservoir, the container for the oil. Okay, this is the typical hydraulic unit, central unit. In this particular case, the motor is a DC motor. Once again, in some cases, like the previous micro video clip, is with the AC motor. And of course, there are other possibilities like this. This is another great example. This is for the trim of an steam drive system. We have the motor, reversible motor. The green color is for one type of rotation. The blue one is for the other type of rotation. The valve body, the reservoir, and the solenoid control box. This system operate in this way.
Other perfect example of a hydraulic unit, electro-hydraulic unit, are the trims for the steam drive system. This is the typical gimbal of the trim tabs of the trim system for an steam drive system. But the secret for those hydraulic actuators is this element. This is a typical central hydraulic unit. The motor is a DC reversible motor, 12 volts or 24 volts. Here we have the valve body, and in the bottom we have the reservoir. And we have two relays to control the rotation of the motor clockwise or counterclock. You remember the video in my electrical class, how to rotate a DC motor with a solenoid control box? You remember that video? That video clip is a wonderful video. Check that video in order to understand how can you change the rotation of those DC motor reversible motors. Okay, this is a typical central hydraulic unit. And of course, you can integrate in a central hydraulic unit, big one, that unit. Normally is independent, but you can integrate also. Once again, is an electric motor DC reversible motor, 12 volts or 24, the valve body, the reservoir, and the relays or solenoid control box. It's simple because you have a rotation clockwise if you bring the power to the green, or rotation counterclock if you bring the power to the blue one. Like this. If you bring the power to the green, if you bring the power to the blue one, this is a perfect electro-hydraulic system that can be integrated in the main central unit.
Another great example is the trims. This is the pump for the trim tabs. We have a motor, DC motor, reversible motor, the yellow and the blue one, and we have the solenoids, the reservoir, and the ports. This is another great example of a micro central hydraulic unit. This system operates in this simple way.
There are trim tabs with flaps like this, with the electric motor, DC motor, reversible motor, 12 volts or 24, electro-hydraulic. And the actuator, this actuator is like the actuator that we have on the screen, single port, single shaft, a spring return. This one is a spring return. If I open this element here, a big spring is extended, like the picture that you have on the screen right now. This is a single port because the fluid enter over there and return over there. This is the only port that we have. The fluid enter and return. This is a single port, a spring return actuator. There are other mega yachts with big flaps, like the video you have on the screen, and big rams, big cylinders, big actuators. Those actuators require more than 100 psi. Those actuators, those flaps, can be integrated into the central hydraulic system.
Once again, we need great lines, we need excellent pumps, and we need good actuators. According with the pumps in hydraulic applications, marine applications, are considered positive displacement pumps. Positive displacement pumps. There are different type of pumps. There are gear pumps. Yeah. There are vane pumps. There are also piston pumps. There are different type of hydraulic pumps that we are going to use depending of the application. But all of them should be marine approved. In some cases, the pump is a mechanical pump. Of course, it's a hydraulic pump, mechanically activated, and that pump should be integrated to the main engine or to the generator or to the transmission of the main engines. The name of that pump is the PTO. In this boat, we are going to analyze where are located the PTOs and where is located the hydraulic central unit. This boat uses a V-drive transmission. What engines V-drive transmission? Those are the V-drive transmission. That's the V. And the PTO is integrated with the transmission. The gears are connected with the transmission. This boat have two PTOs. One PTO in each main engine. In the starboard engine, a starboard PTO drain power, and this one is the PTO for the port side. Both PTO. Those are the hydraulic, the central hydraulic pumps. The PTO is the generic name for those hydraulic pumps connected on the transmission or connected on the output shaft of the engine. And those hydraulic pumps supply fluid when the engine are running or when the generators are running. When the engines are off, the PTO is disconnected and an electric motor supply the power for the valve body. We are going to analyze in a couple of video clips that situation in boats. In other words, the hydraulic system in boats have redundancy. What is the meaning of that? Normally, when the main engines are running, the PTO supply the hydraulic fluid for the hydraulic systems. When the engines and generators are off, there are electric motors that move the pumps and the hydraulic systems work properly. All right, this is very, very, very important. Other important consideration that we need to keep in mind is the quality of the fluid. The fluid should be hydraulic fluid. I recommend always use the fluid recommended by the manufacturer. In some cases, in boats where all the hydraulic systems are integrated in a central unit, the engineers use hydraulic oil recommended for marine applications, like this. Yeah, I recommend follow the manufacturer recommendation and use the best oil as possible. Never try to use generic oils. Never try to use clean oils. Those oils that the people collect from the garage and added additives in order to clean and after that resell again. No, I recommend use original oils recommended by the manufacturer. This is important. The life of the hydraulic systems depend on the quality of the oil. For that reason, it's important in the reservoirs verify constantly the level of the oil and the color of the oil. If the color of the oil become milky, you need to stop the systems immediately and verify where is the water entering in the system. In this particular example, in our boats, there are a lot of possibilities for intrusion of salt water into the hydraulic system. For example, the rams of the flaps, those rams that we have on the screen right now, those flaps are exposed directly to the water because the flaps for twin taps are submerged in the water. If the O-rings, the gaskets on the shaft, on the rod, are broken, the water enter in the system and that water contaminate all the hydraulic system, not only the trims. This is one possibility. There are a lot of elements exposed on the water. For example, the stabilizers, the fins of the stabilizer, those actuators are exposed to the water, are submerged in the water. If the rams have leaks, the water penetrates in the system and damage the system. When the oil is mixed with the water, there are a lot of inconvenience. Immediately the temperature of the oil increased dramatically, and some motors, some actuators work erratically and work like intermittent, not constant, no soft movement. This is an indicator that the oil is milky. Other important consideration in relation with the fluid is the additives. I don't recommend additives, especially in this type of system. I prefer that flush the system and replace the oil for fresh oil. The recommendation is once per year in a typical central hydraulic unit, but once again, depend on the manufacturer recommendation. Other important consideration, because we are going to talk about the body valves and the solenoids and the solenoid control valves. We are going to use too much solenoid valves in order to interrupt the flow of the fluid for some equipment, in order to activate some equipment. We are going to use a lot of solenoid valves. For that reason, I want that we refresh quickly the process to check solenoid valves. The solenoids can be used in other type of application like this. This is a solenoid. When the solenoid is powered, positive and negative, immediately the plunger closes the valve. This is a solenoid valve to control the movement of the fluid. What type of fluid? Water, gasoline, diesel, gas, alcohol, any type of fluid. The fluid can be controlled. The fluid enter here and continue over there. You see the shape of that valve. Okay, when the plunger is off, the valve is open and the fluid pass. When you activate the coil, the window close and the fluid no pass. This is a typical solenoid valve or shut-off valve. Where you found this type of valve in a boat? The shut-off valve for fuels in the output of the fuel tanks, or the shut-off valve at the entrance of the fuel injection pump to avoid that the fuel enter in the fuel injection pump and the engine stop, or the idle the idle solenoid on the carburetors to control the idle and to control that the engine start and stop. There are other applications in hydraulic system. In air conditioning system, we use solenoid valves. In an air conditioning system, the solenoid valve used to reverse the cycle from heating to cooling or cooling to heating. Is a solenoid valve, three-way valves that control the flow of the refrigerant to the evaporator or to the compressor, heating or cooling. There are other applications that we are going to study in our class of auxiliary system or hydraulic systems, and also in our class of air condition. We are going to study other type of solenoids. Okay, guys, those are the main components of hydraulic system. The last elements are the cylinders. We have a lot of cylinders, different type of cylinders, but the most common cylinders are cylinders like this. This is a double port, one port for input, other one here. This is double port, single shaft, double port, single shaft, exactly like the cylinder that we have on the screen right now. And we have like this. This is double port, but this is double shaft, double port and double shaft. This internally, this shaft is like the picture that we have on the screen. And of course, because this shaft is with the piston in the middle, the force produced in both sides is exactly the same. This is the properly explanation why in this type of cylinder, the force produced in each shaft is exactly the same. For that reason, this type of shaft is commonly used for power steering, because we need that the force applied in both sides should be equal. If not, when you move your wheel in one direction, it's soft, but if you move the wheel in the other direction, it's hard. For that reason, this type of cylinder, double port, double shaft, is the recommended for steering applications. And this type of cylinders, double port, single shaft, is used for different applications. For trims, is used for actuator for garage doors, like this one. Look at the movement of that piston. Yeah, that piston is perfect. It's double port, single shaft. look at the bracket and the force produced for that port, or the cylinder, the actuator used in the davit that we have on the screen right now. This is another great example. Or the other davit, that one, or the pasarela that we have over there. This is a great example. This is a cylinder, double port, single shaft. All right, those are typical cylinders. There are other type of cylinders, like the cylinder used on the twin tabs. Okay, is single port. For that port, enter and return the fluid, but the return is with a spring return. In this cylinder, the force of the piston in both directions is equal. Why? In this video clip, we are going to analyze the difference in between an actuator, double port, double shaft, like this. This is one shaft, other shaft, one port of fluid and other port of fluid. This is a double port, double shaft. And we are going to analyze with respect to the other one. Is double port. This is one port here, the other port over there, and only single shaft, one shaft. Okay, this is double port and single shaft. And we are going to analyze why the double port, double shaft is commonly used in a steering application. Alright, why? Because the force produced in both sides, in both directions, is equal. We are going to check why. Alright, remember, if we have a hydraulic circuit completely closed, completely hermetic, it's because the pressure is constant. Okay, we are going to suppose that both scenarios in this example, the pressure is constant. Okay, how much is the pressure? We are going to suppose that that pressure is 800 psi. Is the example for today. And we are going to check the area of the piston. Alright, the area of the piston here in this point, I'm going to suppose that this is the piston. Okay, in that case, the area of the piston, I suppose that is 4 square inches. And we are going to suppose that the area of the rod is 1 square inch. Okay, the area of the rod, 1 square inch. The big area of the piston, this one is 4. How much is the area here in this part, in this portion? How much is? Yes, it's 4 minus the area of the rod. The area in this portion is 3 square inches. Right? Alright, perfect. We are going to analyze how much is the force. How much is the force when the fluid enter here, produce the force number 1. This is the force number 1 in this direction. Okay, the force number 1 is a force in this direction, is equal to the area, the pressure divided by the area number 1. How much is the pressure? Is 800 psi divided by the area 4 square inches. We have 800 divided by 4, and we have a 200 pounds. Oh, nice, 200 pounds in this direction. In this direction is 200 psi. And what about in this piston with the force in the other direction? The force in this direction, the force number 2. The force number 2 is the force in this direction, is the pressure divided by the area, the blue area, this one. Is 800 divided by 3 square inches. 800 divided by 3 is 266.6 pounds. The force in one direction, in the blue direction, is bigger than the force in the red direction. Mm-hmm. For that reason, this type of cylinders, double port, single shaft, is used for example, in your boat, the garage door, that exactly that cylinder, or is used in some application for example, for basically for windows, for doors, where you need high force in one direction and probably the return is by gravity. You don't need high force in the return. Those cylinders, double port, single shaft, are used in those particular situations. We are going to analyze the second one. Okay, in the second one we have this situation. This is the situation, double shaft, double port. Okay, what happened when we analyze the force in one direction? We are going to check this force in this direction, and we are going to analyze this force, the force number 2, and we are going to analyze the force number 1. Okay, the force number 1, and we are going to suppose exactly the same dimensions. The area of the rod is 1 square inch, and this area is 3, and this area is 3. Alright, in this particular case, both forces are equal. This is 800 divided by 3, and the force number 2 is 800 divided by 3 square inches. Okay, in both cases, the force is 266 and 266, because the area in both sides of the piston, is exactly the same. For that reason, this type of cylinders, double port, double shaft, are commonly used in a steering application. And finally, we have the telescopic actuators, like the actuator that we have in this gangway or pasarela. This is the typical actuator. It's telescopic. It's very common in forklifts. It's very common in gangways, in pasarelas, like this, because one extend until this point, and the other one continue, and the other one, and finally extend completely the pasarela. This is a great example of a telescopic actuators or cylinders. Yes, there are different possibilities, but all of them use the same principle. Now the secret is integrate all of those systems in one system. Concentrate all the systems in one central hydraulic unit. And this is the example that we are going to explain in the next coming episode. It's a wonderful example. We are going to visit an azimuth 85 feet with a surface drive propulsion system, and in that boat we are going to analyze the central hydraulic unit with an expert in hydraulic systems. And after that we are going to visit another boat of 120 feet with a different hydraulic system integrated in one central hydraulic unit. This is a great example. But what is the meaning of that? Yes, I can integrate, for example, the bow thrusters, steam thrusters. I can integrate also the pasarela, the gangway. I can integrate the davit, the crane. I can integrate the garage door actuators. I can integrate the flaps for the trims. I can integrate the harness-on system, the surface drive system. All of those systems integrated in one central unit. Oh, what is the secret of that? The secret is calculate the motor and the pump appropriated to supply the amount of pressure required for all the systems, if the systems are working together at the same time. This is difficult? No. The secret is calculate how much is the total pressure. This is the example. In this example, we have the bow thruster, we have the gangway or pasarela, we have the davit, we have the garage door ram, we have the trim tabs, the flaps, and look at the pressures. The pressure, those are the individual pressure per each systems, and those are the total pressures. The total pressure is 3,800 psi, and the total flow required is around 20 gallons per minute. Yes, you need added the flow required per each system plus the pressure. flow and pressure, flow and pressure, flow and pressure. And after that you add it. And this is the total flow and the total pressure that you need in the pump. After that you enter in the catalog and you select the pump. You select the PTO pump recommended, and you select the electrical pump for AC or DC motor recommended with that capacity. And you create the system integrated with both of them. This is the next episode. It's a wonderful episode. This is the secret, and I am going to explain in the next coming episodes with too much details the procedure to do that integration. And in the future you will be the engineers, the administrator of the boats, and I want that you understand the system. I want that you understand the procedure to calculate when you try to integrate an extra equipment in the system is possible. Normally in those systems you have extra fittings to connect more systems, but the only that you need to keep in consideration is if you have a space to install more equipment, because when you added more equipment you suction more pressure, and probably the system is not enough, the pump and the motor. The hydraulic systems are reliable. I love it, those systems, because produce excellent power, excellent force, excellent torque, and with high quality. I want that you be familiarized with those systems. Don't forget that in all of those systems you need to be clear the hydraulic schematic of your particular boat. Keep in your hand, keep in your office the schematic, exactly the same like the wiring diagram, you remember? Exactly the same. Those diagrams are critical, because if you are the engineer of a boat and you have problem, for example, with the flaps of the trim flaps, you need to isolate the systems, and probably you need to go into the boat and move that particular actuator with your hands, because the solenoids are broken or the signal is not coming in, and you need to go over there and with the handle activate the solenoid and move the solenoid in other position. Is with this handle. I am going to explain in the next coming episode the procedure to activate or deactivate, engage or disengage the system manually. Yeah, all the solenoid control valves, they have the possibility to activate or deactivate manually. Okay, my friends, I hope you enjoyed this video, and now we are going to analyze in the next coming videos the process of integration.